Today, let's learn about linear equations in two variable. As you all have studied linear equations in two variables in your ninth grade, you all know that a linear equation is of the form of ax plus by plus c equals to 0. This is the standard form of a linear equation with two variables. It has two variables a and y. It has two variables x and y. A, B, C are coefficients or constant terms. So a is the coefficient of x, B is the coefficient of y, and c is the constant term. This is only one equation. Now why is this called a linear equation? Because if we try to plot this on a graph paper, we will get a straight line. So whenever for an equation you get a straight line, you say that it's a linear equation. It can be of one variable also, but here we are using linear equation in two variables. Now what are we going to do in this chapter is that we will take two equations together. Let's say you have two equations. Uh, First equation is a1x plus b1y plus c1 equals to 0. Second equation, take it as a2x plus b2y plus c2 equals to 0. These are two equations, standard form of those two equations. Let's take an example also now, and we will study what is the meaning of these equations and why do we have to use it. So first equation that I'm taking is over as x plus y equals to 10 and x minus y equals to 2. Here, these two equations I've taken as this as example. If you see x plus y equals to 10, x minus y equals to 2. Now, if I substitute here x as 6 and y as 4, what will I get in the first equation? 6 plus 4 coming out to be 10, and in the second equation if I substitute 6 minus 4 coming out 2. So the value of x and y is satisfied by both the equation satisfy these two values of x and y. So these two equations are called as simultaneous equation. What are these two called as? Simultaneous equation. Why they are simultaneous equations? Because they x and y, these value x and y is satisfying each of these equations. Fine. So the value of x and y is being satisfied by both the equations. So these two linear equations are called as simultaneous equations. Clear, students? Now let's move to another thing. These linear equations are of two types. These linear equations are of two types. What are those two types? One is consistent system of linear equations. It's called as consistent system of linear equations. Another one is inconsistent system of linear equations. Now, what is the meaning of this consistent and inconsistent? If the two equations have at least one solution, meaning they should have a pair of value of x and y that satisfy those equations, then they're said to be inconsistent. If the two equations have no solution, if the two equations have no solution, they are said to be inconsistent. So consistent meaning they should have at least one pair of solution, one pair of x and y value which satisfy the two given equations. And if there is no solution, means there is no value of x and y which will satisfy the given equation. Now this consistent equation is further divided into two parts. One is called as intersecting lines, because when we solve them, when we get the different values of x and y, you can plot those values, and when you plot those values, you get those lines as intersecting lines. You will get coinciding lines when we plot these values. Okay, so intersecting lines means only one solution, only one solution. Here I said that consistent means at least one. So if there is only one solution, they are said to be intersecting lines. The system of linear equations are intersecting lines. Then coinciding lines means there are infinitely many solutions. Infinitely many solutions, they are said to be coinciding lines. When you have inconsistent system of linear equations, meaning whenever there is no solution, then the lines are said to be parallel lines. We can know this thing after plotting that, the lines. Then only we will decide that they are intersecting, coinciding lines and parallel lines after getting the graph of the equations. Now, sometimes you have given the equation and you just have to, by seeing it also, you can tell whether it is a intersecting line, coinciding line or parallel lines. We can take example of that. Let's take the first example only, which we have taken. X plus y is 10 and x minus y is 2. In this case, what is, let me represent it as in this form also. A1x plus b1y plus c is the standard form. A2x plus b2y plus c2, and this is c1, sorry. That's the standard equation. Now, what is the value of a1 over here? A1 is 1. A2 is also 1. So what's a1 by a2? 1 by 1. Fine. Now let's see what is b1 and b2. So what will be b1 by b2? That's 1 by minus 1, which is minus 1 by 1 also you can write. What is c1 by c2? That's, if you bring this 10 and 2 on that side, so you can write 10 by 2 or minus 10 minus 2. So that is 5 by 1. Now from here, if I see, I have a1 by a2 is not equals to b1 by b2, because 1 by 1 is not equals to minus 1 by 1. So whenever a1 by a2 is not equals to b1 by b2, we say the lines are consistent and have unique solution. Unique solution meaning they are intersecting lines, meaning they are intersecting lines. We can plot this equation also. Let's say the same equation I'll take. X plus y is 10 and x minus y is 2. So from the first equation, if I take few values of x and y, when say x is 6, y is 4, x is 5, y is also 5, x is 4, y is 6. This is first equation. Let's take the second equation also. This is x plus y equals to 10, because if you substitute x as 6, y will be 4, like that. Second equation is this. So let's get few values for this also. Same thing, when x is 6 here, y should be equals to 6 minus 4 will give you 2. Fine. Now, when I say x is 5, what will be the value of y then? Then it will become negative. 5 goes over there, minus 3. No, 5 minus 2, 3. Y will be 3. Okay, now let's say x is 4. When x is 4, what will be the value of y? 4 minus 2. When x is 4, this will be 2. 4 minus 2 will be 2. Okay, now this is done. Now let's try to plot it. Let's try to plot it. We need the value, so I'll take it. X and y both are positive only, so let's take only the positive values. maximum till 6 it's going, so 0. This is your x-axis, this is your y-axis. We'll take divisions of 1 only. 1 centimeter, 1, 2, 3, 4, 5, 6. You people have to plot it on graph paper. I'm only doing on the board just to explain you. 3, 4, 5, 6. X is 6 over here, y is 4. So x goes over here, so y 4 from here. So this is your 6 and 4. Then 5 and 5. 5 and 5. Approximately will come somewhere here. 5, 5. And then it's 4 and 6. It's coming like this. 4 and 6. So let's draw the line. It has to be a, you using a scale, please draw the line. So it has to be a straight line coming. That's the first equation. What is that? X plus y equals to 10. Now the second equation, 6 and 4. It also has the same point. Then 5 and 3. 5 and 3 will be here. Then 4 and 2. That will be here. So let's join these points also. This is the second equation, and you see they are intersecting lines. Y minus x minus y is 2. Now the point of intersection of the lines is what? Point of intersection you can see over here also. It's 6, 4. That is 6 and 4. So the two lines are intersecting, means they are consistent. They have a unique solution. That's the meaning of intersecting lines. Now let's take an example of line which has infinitely many solutions. Which has infinitely many solutions. Let's take pair of equations as 3x minus y is equals to 2. 9x minus 3y equals to 6. Now, from here only, let's first check what is a1 by a2. That's 3 by 9, which is 1 by 3. A1, I'll explain again, is the coefficient of this x of the first equation. A2 is the coefficient of x of the second equation. Then b1 by b2. b1 is the coefficient of y of the first equation, which is minus 1. b2 is the coefficient of y of second equation, that's minus 3. This is also 1 by 3 coming out. Now, what is c1 by c2? These constant terms. So that will be 2 by 6, 1 by 3 again. So now you see here 1 by a1 by a2, b1 by b2, c1 by c2, all are coming to be 1 by 3. So whenever by seeing an equation only you got this thing that a1 by a2 equals to b1 by b2 equals to c1 by c2, then the two equations are consistent but have infinitely many solutions. They won't have any single solution. They will be many solutions, and the lines are coinciding. What's the meaning of coinciding? They overlap each other. When you plot the points, you will see they will overlap each other. Let's take 3x minus y equals to 2 first. 3x minus y equals to 2, and the second equation 9x minus 3y is 6. Let's try to find out the values of x and y. If you have a problem in finding the values of x and y, you can take try to take one variable in terms of other. From here, if you can say that, what is y? If you take y over here, so y is 3x minus 2. Okay, from here it's easy to substitute now. If you put x as 0, so if x is 0, what will be y? Y will be 3 into 0 minus 2, which is 0 minus 2 minus 2. You can do this calculation in your mind. There is no need to do it in fair work. So x is 0, y minus 2. But to practice, first do it like that, because initially you will face problem in doing that. So when you put x equals to 1, when I put x equals to 1, so 3 into 1, so y will be 3 into 1 minus 2. So 3 minus 2 is 1. You can take further more values also if you want, but two values are enough to plot the graph. Sometimes you need one or more value. So when you put x as 2, let's say when I put x as 2, when I put x as 2, what will be y? 3 into 2 minus 2, which is 6 minus 2, 4. So x is 2, y is 4. I hope this is correct. Yeah. Now from here, let's say, what will I do? I'll take 3y equals to 9x minus 6. So y is what? 9x minus 6 by 3. Now I have to choose value of x so that I get multiples of 3, because I need to divide. You try to get whole numbers, but if you're not trying getting whole numbers, then try to get in point 0.5's values, like 0.5, 1.5, 2.5, so that it's easy for you to plot on graph paper. Clear? Here you can easily get multiples of 3. Why multiples of 3? Because you'll be dividing it by 3 to get a whole number. Let's say if I put x as 0. When I put x as 0, this whole terms become 0. So what will be the value of y? 0 minus 6 is minus 6 by 3, which is minus 2. So minus 2. You got an intersection over here if you check. Okay. Now let's put x as 1. Fine. Now put x as 1. When I put x as 1, what will I get? I'll get y as 9 minus 6, that is 3 by 3, which is also 1. So one more point is similar over here. Yeah, you see another point also same. So it has got same solution. 0 minus 2, 1, 1. 0 minus 2, 1, 1. So means 2 and 4 will also be the point for this. Clear? Now let's start plotting it. What all values I have to take? I have to take only 0 minus 2, 1, 1, 2, 4. So minus is, let's see where side it is going. X, y, x dash, y dash, 0. This is going to minus 2, I think. Yeah. 1, 2, 3, 4. Let me just once more check it. 4 is in y, not in x. X to sif only going to 2. Okay. Fine. So 1, 2, 3. No negative values are there. So let's just not take it. Yeah. So it was what? It's 2 and 4 is there. So 2 and 4 is over here. 0 minus 2 is there, it is over here, and 1 1 is there, this is over here. Both the equations have same points, 2 4, 1 1, and 0 minus 2. So when you plot it, you will get a single line for both of them, because they are coinciding lines. They are coinciding lines. Is this clear? It has to be straight line. You have to draw with the scale. Okay, students, now let's move to the last set of equation, that is you have parallel lines. What do you have? Parallel lines. So let's take one example for parallel lines also. Suppose we have this set of equation. 2x minus 3y equals to 5 and 6y minus 4x equals to 3. Now first, by checking a1, a2, b1, b2 and c1, c2 ratio, let's see if this is what type of equation. So a1 by a2 is what? 2 by minus 4, not 6. Here the coefficients, if you say, just arrange this one. It's 2x minus 3 by 5 is okay, but this is minus 4x plus 6y is 3. Okay, so that's 1 by minus 2. b1 by b2 is how much? Minus 3 by minus 4, which is 3. Again, I wrote it wrong. Say, sorry. b1 by b2 will be minus 3 by 6, which is also minus 1 by 2. I can write it in standard form. Then c1 by c2 is what? 5 by 3. So from here we see that a1 by a2 and b1 by b2, they are equal, but c1 by c2 is not equal. So what will I write? That as a1 by a2 is equals to b1 by b2 but not equals to c1 by c2, which is 1 by 2 minus 1 by 2 minus 1 by 2, both are equal but not equals to 5 by 3. So the system of equations are inconsistent. Okay, system of equations given are inconsistent and have no solution. No solution meaning they are, if you plot the graph, you will get parallel lines. Clear? Now let's draw the plot for these. 2x minus 3y is 5, and another is minus 4x plus 6y is 3. Let's see if we'll get whole numbers in these or no. Okay, let's start with from here. Here, what can you say that? What is 2x? 2x is 5 plus 3y. Okay, now let's start plotting it. Not plotting, just finding the values first. X, Y. If you put X, Y as 0, you'll get a decimal number over here, yeah? But in points, yeah? And if you put, okay, Y as 1. Let's put Y as 1. What you will get? 5 plus 3. I'll just start solving. 5 plus 3, which is X is 8 by 2. So you will get it as 4. Clear? 0 won't work, but minus 1 will work. Yeah, 0 may you will get fraction. So let's say X as 0, Y as 0. When I put Y as 0, so no, Y as 0, again decimal I'll get, I said. Let's put Y as minus 1. When I put it as minus 1, 5 minus 3 will be 2. So 2x will be 5 minus 3. So x will be 2 by 2, that is 1. So you will get it as 1. I think you will get the line from there. Any other point you want to keep? If I say Y as 4, no, 3. Yeah, I can try 3 also. I can try minus 3 also. Let's say y as minus 3 if I put. When I put minus 3, it will be minus 9. So 2x equals to 5 minus 9, which is minus 4. So x will be minus 2. You can try this also here. Fine. Now let's move to the next one. Here what will I do? If I take it over here, 6y equals to 3 plus 4x. Okay. It's easy. First point is easy for us to get, because if we put x as 0, we'll get, but we'll get in decimals over here. There is no chance we are getting whole values. Bigger ones will be there. Yeah. Now let's I put x as 0. When I put x as 0, it's only 3. So y will be 3 by 6, which is 1 by 2. I can say 0.5. That can be done. Okay. If I put it as 1, that won't work. If I put it as 2, 8 plus 3, 11. No. If I put it as 3, I think that will work. Let's put it as 3. If I keep it as 3, 12. Yeah, 3 will work over here. Let's keep it as 3. So when it is 3, 6y equals to 3 plus 4 into 3, 12. 12, that's 15. So y is 15 by 6, which is 5 by 2. That's 2.5. You got 2.5 also. Fine. Now, will minus work over here? Minus 2. So that's minus 8 plus 3. No, 5 by 6. You'll get something in decimal only, yeah? Any other value? Minus 1, no. Minus 4. If I put, what will I get? 16. No, that also will not work. Let's say minus 3 only I'll put. Okay, let's say keep it minus 3. If I keep it as minus 3, what will I get? Let's put the value. Where is the board? Marker gone. Yeah. So let's put it 6y equals to 3 minus 12, which is how much? 6y equals to minus 9. So that's y equals to minus 3 by 2. That's minus 1.5. These values I got over here. Fine. Now let's plot them in a graph. Let's try to plot, because 0.5 values is easy to plot. So how will I take it? I'll just write down the values again over here. First, let me just take the graph. Y value is going from till minus 3, and then on top it has to be till 2.5. Okay, 2.5 to minus 3 I have to take. So I think this will be enough. 0, yeah. So I'll start from 0.5, 1. You can take 0.5 gap also. 1.5, 2, and 2.5. Then it will be easier to plot. Then x is negative going, yeah, till -1, -2, and I think -3 also. Fine. Here I will take again what? 1, 2, 3, 4. Y also going in that direction, so that is why I'm taking y here below will be negative zero point 0.5, negative 1, negative 1.5, and it's going till -3. So -2, -2.5, let's go a little further more, -3. X dash, y dash. Now let's plot them. So I have the points as, oh my God, wait. I have the points as 4, 1. So 4 and 1 is the y over here. 4 and 1. Okay, then I have 1 minus 1, 1 minus 1. Then I have -2, -3. -2, -3 is below. Let me write it, then I'll plot it. -3. And here on this side it is, what all points are there? 0, 0.5, 3, 2.5, and -3, -1.5. So let's now plot them. Okay, here is left -2, -3. It's over here. -2, -3. Let's just join this line. Use a scale to join. I'm just trying to make it a straight line, but didn't come out as a straight. Yeah, it's a straight line. If you plot it, then 0.5, 0.5 will come over here. 3, 2.5, 3 and 2.5. That's 3 and 2.5, and then it is -3 and -1.5. Will be somewhere here. Okay, now when you plot it using a straight lines, yeah, see, now what you see, the lines are parallel to each other. It's visible over here that the lines are parallel, means there is no point of intersection. A single point of intersection is also not there. So lines are parallel, inconsistent, having no solution. So we have done in this video three type of graphs. One is for intersecting lines. Let's just brush up. So intersecting lines, the standard form of line is a1x1 plus b1y1 plus c1 equals to 0. a2x2 plus b2y2 plus c2 equals to 0. For intersecting lines, just by seeing the lines and finding the ratio, you can tell whether they are intersecting or no. So it will be a1 by a2 is not equals to b1 by b2. You don't have to check c1, c2 here. So the graph will be intersecting, and it is only 1 point. Only 1 point, meaning we say that it is a unique solution. We say it as a unique solution, means there will be only one value of x and one value of y that will satisfy both the equations. Fine, that is the first one, intersecting lines, and that's consistent also. The system of equation is consistent. Second one is the lines will coincide. Coinciding lines means they overlap each other. In that situation, what is the condition to be satisfied? a1 by a2 equals to b1 by b2 equals to c1 by c2. Now here coinciding means lines means they have many solutions, infinitely many solutions. So the lines will be, here the lines were like this, any point, and here the lines are one line on top of the other. Okay, that's coinciding lines, and these two are consistent equations, simultaneous equations. Okay, then the third one, what you will check, that a1 by a2 is equals to b1 by b2, but it is not equals to c1 by c2. Then the lines are parallel lines. Then the lines are parallel lines, meaning there is no solution and the system of equation is inconsistent. I hope till here this part is clear. How to check from an equation whether it is consistent, inconsistent, having a unique solution, having infinitely many solution, or having no solution. So, and also after you plot, you should know that it should be a intersecting line, should be a parallel lines, or should be the coinciding lines. This method what we studied today is graphical method of solving a system of linear equations. In the coming videos, we'll study about substitution method, and we're going to learn about elimination method. Okay, that's it for today, students.